Hey guys, welcome to mechanical energy. Now, mechanical energy is quite an interesting concept. I think it's really awesome. And it's not that difficult. So I'm going to do my best in this lesson to explain exactly how it works. Okay, so what I want us to do is I want us to think about, okay, let's say we've got the ground. Okay, so I'm going to draw a ground. That's the ground. And then we've got a roller coaster. Okay, so let's say we've got some type of roller coaster like this. Okay, and on that roller coaster we have, well, on the track we have a roller coaster. So the actual vehicle that the people go in. Okay, so there and there, and there's people inside the roller coaster, and there's their hair. Woohoo! And they're about to go down. Okay, now this object, which is the roller coaster and all of the people, has energy. Energy in the form of, we have two types of energy that we're going to look at in grade 10. Number one is going to be potential energy. Potential energy is the energy that the object has if it has height above some type of reference point. So let's say the ground is our reference point, so that's the ground. Then can you see that there's a height over here? So because there's a height, then this object has potential energy. If the height was 0, so if the roller coaster was down here at the bottom, then there would be no potential energy. Okay, so potential energy is energy due to height. Okay, then there's another type of energy that we're going to look at in grade 10, and that is kinetic energy. These are actually two very important types of energies that they use in real life when they study these things, and in grade 12 you're also going to go into this in detail. Grade 11, for some reason, they just leave it out, and then grade 12 it comes back. So kinetic energy is energy due to how fast the object is moving. Okay, so if this roller coaster, let's say this roller coaster is at a height of, let's say that it's at a height of 10 meters, and let's say that it has a velocity, it's going in that direction, and let's say it has a velocity of 3 meters per second. So because it's got a height above a reference point, it's got potential energy, and because it's got velocity, it's also going to have kinetic, because kinetic is energy due to how fast, and how fast is velocity. Okay, so to calculate the potential energy, we're going to use this formula over here, which they'll give you in an exam, and then to calculate the kinetic energy, you use this formula, half mv squared. Okay, so let's just talk about each of those things. So the m is the mass. G is a constant number. You just need to remember 9.8. H is the height above a reference point. We'll get more into reference point. Most of the time the reference point will be the ground, but not always, but most times. Okay, and then let's have a look here. Here we can see there's also a v. So v is velocity. Okay, so if we had to just go practice this quickly, let's quickly tell you that the mass of the roller coaster and all the people is 1,000 kilograms. So if we had to go calculate the potential energy, you would say 1,000 for the mass, multiplied by 9.8, multiplied by 10 for the height. And if you had to go and work this all out, you would get 98,000 joules. Now, energy is measured in joules, but you don't give it a direction. Energy is a scalar. So let's write that. Energy, by the way, for the rest of this lesson, once I've finished with this slide, we're going to be looking at some cool examples, like this, for example, where we're going to be doing calculations and everything, okay, in this lesson right now. So just stick around. So energy is a scalar. So energy is a scalar, and so it has no direction. Now, if we had to go and calculate the kinetic energy, then that is going to be equal to a half multiplied by the mass, multiplied by the velocity, and then a lot of learners forget about this 2 over here. So just remember to include that, and then if you had to go work this out, you end up with 4,500 joules. Okay, so some of you might be thinking, Kev, where does mechanical energy come into it? My bro, you're talking about potential energy, you're talking about kinetic energy. Where does mechanical energy come in? Well, that's a good question. So mechanical energy is the total energy that the object has when you add the potential and the kinetic. So if you add all of that together, the potential and the kinetic energy, that is mechanical. So mechanical energy is potential energy plus kinetic energy. Okay, so for this object it would be 98,000 plus 4,500, and that would give us 102,500 joules. So mechanical energy is simply potential energy plus kinetic energy. So remember that, okay? Now, we are about to talk about something so important, and it's so amazing. I think it's super, super cool. So what happens in real life is the following, okay? This roller coaster is on its way down the slope. So what is going to happen to its potential energy? Think about that carefully. Remember, potential energy is this one. So potential energy is equal to mass multiplied by 9.8 multiplied by the height above the reference point, which in this example is the ground. So when the roller coaster gets to, let's say, this position over here, if you measure its height above the ground, it's going to be less than 10. So would its potential energy go up or down compared with when it was over here? Some of you might be like, Kev, it's going to have more energy because it's going to be going faster. But you're not listening to me then carefully. Remember, I'm asking you, what is the potential energy? You're talking about kinetic energy, if that's what you're thinking about. I'm saying, what will happen to its potential energy? So because the potential energy is mass, gravity, and height, the mass is not going to change. 9.8 is a constant, but the height is going to become less. So when it gets to this position, the potential energy will actually be less, okay? Because it's lowering its height. But as it goes down that slope, it gets faster. So what would happen to this part? Well, the half stays the same, the mass stays the same, but the velocity will go up. And so the kinetic energy is going to increase. So what happens is that the potential energy will decrease, but the kinetic energy will increase. And guess what? The decrease in the potential is going to be the same as the increase in the kinetic. So what would happen to the mechanical energy? Well, mechanical energy is actually going to stay exactly as it is. That is the law of conservation of mechanical energy. It says that if we have a system like this that I'm showing you, where we're not worried about other forces like air resistance, friction, you're only going to worry about that stuff in grade 12. But in grade 10, when there's no friction, there's no air resistance, then what happens is that the mechanical energy at this position, and this position, and this position, and any position, the mechanical energy of that object is not going to change. All that happens is the potential might change and the kinetic might change, but it all balances itself out so that the mechanical energy stays the same no matter where the object is. So what we can say is that the mechanical energy at any position, so let's say at position A, is going to be the same as the mechanical energy at any other position, so let's say B. This is a very important thing that you need to understand, that the potential and the kinetic energies can change. They do change, but the mechanical energy never changes from one position to the other position. So remember what mechanical energy is. We said that it is the potential plus the kinetic energy. So if you take the potential energy at any position A plus the kinetic energy at any position A, because remember, you need those two to be added together to give you the mechanical, then that'll be the same as the potential energy at any position B and the kinetic energy at that position B. Now, if you need to expand this even further, we can come up with a really long formula, but it's really easy. We can say that the potential energy at A, now remember potential energy is this, so we could say mgh for position A plus, now we can use kinetic energy, which is this formula, for position A, so we can say half let's write this a little bit better, half mv squared at position A is then going to be the same as the potential energy at B plus the kinetic energy at B. This right here is very important that you understand. It's very important that you understand how I did this part over here, okay? We are going to go do some examples in this after this, but it's very important that you understand what we've spoken about so far. So remember, potential energy, that can change. Kinetic energy, that can change. If the one goes down, then the other one goes up. That's how it works. Because as this roller coaster, for example, if this roller coaster is going down, it loses potential energy, but it also gains kinetic energy. So the one goes down and the one goes up. Okay? But if you add up the potential and the kinetic, that gives you mechanical. And that will never change, no matter where you are in the system. So here's our first example. Now, I've got all the formulas that we know about now. So we know that there's potential energy, which is mgh. There's kinetic energy, which is a half mv squared. We also know that if you add these two together, then that is the when you add these two together, that is the mechanical energy. So we're saying that the mechanical energy at point A is the same as mechanical energy at point B. But now, listen carefully. When I say A and B, I'm not talking about this A and this B. No, I'm saying that this is a formula that you can use between any 2 points. So you could even do it between this point and this point. You could do it between this point and this point. You could do it between, that's everything. So I'm just saying that you can choose 1 point for this one and 1 point for that one. Okay, so it all, as we go along, you'll get used to this. So, and there's different ways of doing it. So the first question says that the object is traveling at 3 meters per second at point A. Okay, so we've got this object that is traveling at 3 meters per second. And the first question says, determine the object's potential energy. So we don't go to this formula because they're just asking for potential energy. So we just go to this formula over here, and we're just going to say the potential energy at point A is equal to mgh, and that's going to be equal to the mass multiplied by 9.8 multiplied by the height, which is 30. Can you see that they're measuring all of the heights relative to the ground? Okay, so we'll use the ground as our reference position for this question. And now if you had to go calculate this, we get 588 joules. Now remember that energy has no direction. So you're not going to say 588 down, 588 up, nothing like that. Okay, so you're going to say 588 joules. Now, the next question says, determine the object's kinetic energy at A. Okay, so now we don't use this formula. We just go calculate its kinetic energy. So we're going to say that its kinetic energy is equal to a half. Now the mass is 2 and the velocity is 3 squared. Remember the square. A lot of learners forget that. And so it has 9 joules of kinetic energy. So before we even go on to the rest of the questions, remember what I told you in the previous slide. We said that this object has 2 types of energy. It has energy because of its height, that is called potential, and it has an energy because of how fast it is moving, and that is kinetic. If you then add those 2 together, then we call it mechanical. So remember that the mechanical energy is when you add the potential and the kinetic together. So this question says, determine the object's mechanical energy. So we're just going to go add those 2 together. So we're going to say 588 plus 9, and that's going to give us 597 joules. Okay, so now that is very important that you understand this. We now have the mechanical energy. We have the mechanical energy. And what did we say on the previous slide? We said that the mechanical energy at one point is the same as the mechanical energy at another point. That is the law of conservation of mechanical energy. So how much mechanical energy does this object have? 597. That means that it will also have 597 mechanical energy over there and 597 mechanical energy over there. You mustn't say that the potential energy is going to stay the same. That won't stay the same. That will become less as you go down, and it will become more as you go up. You mustn't say that the kinetic energy will stay the same. That will become more when the object goes fast, and then it will go down as soon as the object slows down like this. But what you can say is that the mechanical energy stays the same. That we can say never changes. So the next question says, determine the object's mechanical energy at C. You do not need to go and do any calculation because the mechanical energy at C will be the same as the mechanical energy at any position. And so we know what the mechanical energy is over here. It's 597. And so that'll be the same as point C. So we'll just say 597 joules. The next question says, so you notice we're not even using this formula right now. You're not always going to use that formula, okay? The next question says, determine the velocity at point C. Okay, now, there are two ways that you could do this. You could use this formula, or you could, there's a different way. I'll show you both, okay? So, I'm going to start by using this formula, okay? So we know that mechanical energy is equal to potential energy plus kinetic energy. So this is method number one. Now we know the mechanical energy at point C, so we're doing C for all of these. So we could say 597 is equal to the potential energy at C plus the kinetic energy at C. Then we can say 597. Now the formula for potential energy is mgh, so we could say 2 multiplied by 9.8 multiplied by the height at C, which is 25. Okay, then the kinetic energy at point C is going to be a half, and then the mass is, what was the mass? 2, and then the velocity, that's what we're trying to calculate, to the power of 2. Then what you go and do now is you just go and work this equation and try to get this by itself. And so what I'm going to do is I'm just going to quickly go type this part on my calculator. And so we're going to get 597 is equal to, what did we get here? 490 plus, now I'm going to multiply these two numbers together, which just gives me 1 v squared. Now, I'm going to take this to the left-hand side, so you end up with 597 minus 490. Then if you minus those two, you end up with 107 equals to v squared. Then to get the velocity by itself, you're going to take a square root. So if you square root 107, so square root 107, you end up with 10.34 meters per second. Okay, that's one way that you could have done that. So you get 10.34. Another way you could do it is you could, if you want to, just go use this formula. But now we're not going to use point A and point B. We're going to use any point that we already know. So we know point A, so we'll use that one. And then we're looking for point C. This question has nothing to do with point B, so we'll just change this to a C. Okay, now we just go, now think about this. We already know what these two together add up to. We already worked out the potential energy at A. Remember, we got 588, and then we already worked out the kinetic energy over there, and then we ended up getting, what did we end up getting? We got 9. So that, and then if you just add those two together, you end up with 597. But let's say you didn't know that, or like let's say you you didn't remember, or you're in a test, you were stressed, and you didn't really realize what was happening. So you just go fill everything in anyways. So you're going to fill in the mass, you're going to fill in the gravity, and you're going to fill in the height for position A, which is 30. Now this value, we already actually worked it out as 588, but let's say you forgot that. It doesn't matter. And then you're going to say half. Now the mass is 2. The velocity over here is 3. squared. If you had to work this out, you would end up getting 9, but once again, let's say you forgot that. And then what you do is you just say equals, and now you're going to go fill in all of this information. So the mass is still going to be 2, gravity is still going to be 9.8. Now the height is 25, and then you're going to say plus a half times the mass times the velocity, which is what we're trying to calculate. And then you would go plug all of this on your calculator on the left hand side, and you would end up with 597. You would plug this on your calculator, you would end up with 490, and then you would get 1v squared. And then you're going to be at exactly the same position that we were at already. So it's pretty much the same thing actually, but yeah, that's just a slightly different way of writing it if you forgot that we already had the answers. Now, I think that that's enough for one lesson. If you still need more practice with this, then just go on to the next lesson after this, where we will be doing some more practice examples.